Okay, so today we're talking about molecular compounds. And we have to have a different set of writing their names and formulas because our way won't work. Okay? Because molecular compounds don't have charges. I'm not going to be able to use the crisscross. Okay? So we're going to need a completely different set of rules. Okay. So, how are we going to know that it's just that it's a molecular compound? Well, it's going to be made of just nonmetals or nonmetals and hydrogen. These are the ones we've been drawing. We drew pictures of for 3 weeks. Ones where they share electrons. Okay, smallest pieces of molecule. Since everything is a nonmetal, if it forms an ion, it's going to make a negative ion, right? So all the pieces are going to be negative. So it can't be opposite charges holding them together, which means if it's not opposite charges holding them together, that was the whole key to writing these things, was that the charges had to work out so it was neutral. If I've got everything negative, a negative charge and a negative charge will never add up to 0, right? I can't make it neutral. But we didn't try to make it neutral. We made them share electrons, okay? So I can't use charges to figure out how many of each there is. Because I'm not going to have this issue. Think about how many things you drew that had carbon and hydrogen in them last chapter. Can I tell you, ask you to make a compound just out of carbon and hydrogen? Is there one right way to put together a compound of carbon and hydrogen? We did CH4, we did C2H4, C2H6, C3H4. We did all sorts of combinations, right? So the charges don't equal 0 means that we can't use charges to figure it out, which means we have to tell you how many there are. Okay? That's going to make it easier. Okay. Ionic compounds use charges to tell you how many of each. I knew there had to be 4 nitrates for my 1 titanium to make it equal 0. I knew there had to be 2 sodiums for my sulfate to make it equal 0. To make it equal 0, I could use the charges. Okay? Since a molecular compound is not going to do that, and we can put them together in a bunch of different ways, the molecular compound, the name actually tells you how many of each piece there is. So the name is almost going to be like 2 nitrogens and 4 hydrogens. Pretty close to that. It's going to be pretty easy to write the formula if the name is 2 nitrogens and 4 hydrogens. Don't you think? So, but instead of saying 2 and 4, they use prefixes. And I can't remember if the Greek prefixes or the Latin prefixes, they're the ones that have to do with the shapes of polygons. How many sides a polygon has? So those are the ones they use. Some of them you're familiar with, some of them you're not. You don't use it very often. So I need you to know the prefixes up to 10. Okay? That's those, yeah. So we use tetra already, right? Well, so for the prefix means one is mono. One's mono. That's that idea. So one is mono. Would it surprise you that mono meant 1? Okay. Two is di. Does it surprise you that two is di? If you saw di in something in front of something, you would say there was two of them. Can you think of a chemical that has di in it? That's a prefix. Pretty common one. Carbon dioxide. Carbon, two oxygens. So the name tells you carbon and two oxygens. Yeah. What do you think three is? You got to try if you want to get there. Okay. Four, we already learned when we were talking about shapes. You have the four-sided figure, the tetrahedral. So four is tetra. And Tetris, the game, is called because it's got four blocks. 4 blocks in the line, 4 blocks in the square, 2 and 2, an L, 3 and 1. Right? Those are all 4 blocks. That's why it's called Tetris. And even know what 1 for 5 is? A building in Washington with 5 sides? The Pentagon. Pentagon is a 5-sided building. Okay. 6 is actually pretty common too. Hexa, hexagon, the ones you'd put before agon. 7 is rarely used, so you're not used to it. It's hepta. You see it, when you see it, you say, I've learned this list before, and hepta was on it, right? It's one that's, most people know 8 though. 8-legged animal. 9, almost Nana, you know that. Nana, you know that. And 10 is deca, like decade, or deca, or prefix, the one bigger than 10. Deci is 10, deca is 10 bigger. Okay? And they go on from here. Okay? Some people have the irrational fear of the number 13. That's trisdecaphobia. Tris, 3, dec, 10. 3 and 10 is 13. Okay? So they show up in other places. So that's the prefixes. That's how we're going to say how many. We just have to know how to use it. So to write the name, you write 2 words. So every name we're going to do is going to be 2 words because we're only going to do binary molecular compounds. Bigger ones follow a different set of rules. So we won't be learning those rules. So to write the name, write 2 words. First word starts with a prefix to tell you how many. And then you write out the whole name. So you look at the first element, see how many there are. If there's 3, you put tri, and then you write the name of that element. So we said the name was going to be like 2 nitrogens and 4 hydrogens. So if I had something like N2H4, right now I know my first word is going to be 2 nitrogens. I'm just not going to say 2 nitrogens, I'm going to say dinitrogen. Dinitrogen, 2 nitrogens. Second word starts with a prefix again. And then we take the name, but we change the ending to IDE. So we know we're done talking about it. And that's all there is to it. So dinitrogen and 2, 4 hydrogen. 4 is tetra. Instead of hydrogen, I write hydride. Dinitrogen tetrahydride. 2 nitrogens, 4 hydrogens. The issue is you're going to want to do this for everything. Okay, we spent 3 days doing ions because this is too easy. And you're going to want to put prefix in front of ions. But if it's got ions, you don't need the prefixes. And that means it's wrong to include them. Scientists are lazy. They're going to write as little as possible. If I could figure out that there had to be 4 nitrates, I'm not going to write it. But if I can't figure it out, I got to put it in there. I couldn't figure out if this was going to be 4 hydrogens because sometimes we make an H3, right? You do that with a lot of, right? So I can't just say nitrogen and hydrogen. I have to say how many of each because they go together in different ways. Okay? Okay, so a couple of exceptions. It's just about sounding okay. First, we don't write mono if it's the first element. So no name will ever start with mono. If there's one in the first element, you just write that first element. And that's about being lazy. If there were more than one, I would have told you. I would have used a prefix. So in fact, I left the prefix off. So the first word doesn't get the prefix mono. If there's one of the second, it does. Okay, so we leave mono off the first. And actually, something that will tell you all those rules that we just said is that you would call this, what's the name of that chemical? Carbon dioxide. It follows all the rules. Prefix, except no mono to start with. 2 oxygens. Okay. Well, some of our prefixes end in A. So you don't want to put AO or OO together. You drop the one that's on the prefix. In front of oxide, you don't want to have an A in front of oxide because it's hard to pronounce. Although the bizarre one is, if you want to say that you have 2 iodines, you say diiodine. You put both I's. That's all the rules, right there. Sound a lot easier than what we've been doing for 3 days? Don't have to worry about Roman numerals, right? Don't have to worry about polyatomic ions. You just have to say what pieces there are. So, name this compound. So what is in this? There's 2 nitrogens and 1 oxygen. So I want to say 2 nitrogens and 1 oxygen. So 2 would be di. And nitrogen, do I leave it alone or change it? Leave it alone. It's the first word, dinitrogen. First word left alone. That says 2 nitrogens. 1 oxygen. So 1 is mono. Now, you might write monooxide, and then somebody tries to read that.
Well, you can't put the 2 O's.
See why you don't put the 2 O's there? Because that looks like monoxide, doesn't it? The 2 O's? Monoxide. No. So we only put one of the O's. Technically, we lose the one off mono, but we can't tell which one it is. So monoxide. Dinitrogen monoxide. The reason why I want to drop the O's, because somebody behind you is not going to read monooxide, they're going to read monoxide. The ooh. There's 2 words. First word, dinitrogen. Second word, monoxide. I just got rid of that O. So it's dinitrogen monoxide, 2 words. First dinitrogen, second monoxide. I just broke the 2 O's to see it, so that it looks ugly. Okay. Compare that to 1 nitrogen, 2 oxygens. So 1 nitrogen. Okay. So if I want to say 1 nitrogen, so you want to say mononitrogen, but our rule is nothing ever starts with mono. So we just say nitrogen. If there's only one of the first one, we leave it alone. And then 2 oxygens, dioxide. So there's 2 examples with the exceptions built in. right? Left the O off. Carbon monoxide. Hey, what do you think carbon monoxide is? Carbon and one oxygen. CO. I'm surprised we haven't heard more news stories with this cold snap. This is usually the time people start succumbing to carbon monoxide. It's too cold, they lose power, they bring the grill in the house to heat the house, and everything's fine, the meal tastes good, they go to sleep. And that's the end of the story. Don't bring your grill inside, it's bad. They're easy to write, they're hard to say.
So it's
That's two chlorines.
oh, that's cool.
Yes. So two chlorines and seven
No, yes.
dichlor. That's the first word. Leave it alone. Dichlorine. First word we leave alone. Second word we change the ending. 7 is hepta. And it's heptaoxide, so I'm going to leave the A off. Heptoxide. Dichlorine heptoxide. Okay. First word leave alone, except for the prefix. Second word change the ending. So C, Br4. Why don't you go ahead and write it and see what you write. See if you get what I wrote. So write it down on your paper. See if you get the same thing I got. Be just a bit. Carbon tetrachloride. Okay, so you should be able to remember these rules pretty easily if you know the name of this, right? If you know this name, what you did to get that name is what you do to get the other names. Carbon dioxide. Leave the first word alone, change the second one. Prefix for how many? Right? Since you know CO2 is carbon dioxide, just follow the rules that get you there, and that'll get you through molecular compounds. Okay. BaCl2. Ba is barium. So this is Cl is chlorine, so this is barium chloride. So, whoa. Mr. Green, there's two chlorines here. How come it doesn't say barium how come it doesn't say barium dichloride? Because we skipped the first decision. What kind of compound is this? Barium is a metal. Barium's a metal. It starts with a metal, I don't get to use prefixes because I don't need them. Okay? It's a trick question, but it's not really a trick question because that's what's going to trick you on the homework is you're going to want to write prefixes on everything. Okay? You got to stop and make that first decision. Do I get to use prefixes or not? Okay? Is that first piece of metal? Right? So make that first decision. Is it a metal? If it's a metal, you either have metals or you have prefixes, not both. Because if you have metals, you don't need the prefixes because you can figure out the numbers. I mean, if I write barium chloride, I see barium chloride, I'm going to go barium is in 2A, it's 2 plus. Chloride Cl, it's 1 minus. They don't add up to 0. And I'm going to make BaCl2. It's easy to figure out there's a 2 there, so I don't need to write dichloride. Make sense? So that's what, that trick right there, that's what's gonna catch a lot of people, is you're gonna want to write prefixes where where you're not allowed to use them. Oops. Okay, so I'm not gonna spend any time telling you how to go the other way. Let's just do some. I'll pronounce them, you try to write them. Diphosphorus pentoxide. Not hard to write, they're hard to say. Diphosphorus pentoxide. Diphosphorus. Di is 2, phosphorus is P, pent is 5, and oxide is O, P2O5. Diphosphorus pentoxide. It's 2 phosphorus, 5 oxygens. That's what the name says. That's what we write. Okay? How about tetraiodine monoxide? Notice we kept all the vowels here. Tetra's 4. Iodine is I. And it's not an oxide because it says non-oxide. No, that's not what it means. That's the prefix nana shortened up, right? O9. Because that's nana with the A taken off. Right? Sulfur hexafluoride. Number 9, number 9, number 9, number 9. Okay, so it says sulfur. How many? There's 1, right? If they leave the mono off, there's 1. Okay, hexafluoride, 6 fluorines. And one last example, nitrogen trioxide. Nitrogen tri 3 oxide O. Okay. The reason why I want to do this example is those of you paying close attention will notice that yesterday we said NO3 was nitrate. The difference is this is NO3 with no charge. That's nitrogen trioxide. NO3 with that negative charge is going to be part of something else. It's not going to be by itself. And that's when it's the nitrate ion. So that charge makes a big difference in how it behaves. So, does that make sense? So it's not nitrate, it's nitrogen trioxide. Depends on whether there's a charger. Okay? And that is all I